Which of the following best explains why the bond in NH3 is less polar than the bond in HF? Okay, so we have a statement there, and from that statement, we got to find out the correct reasoning. So why is the bond in NH3 less polar than the bond in HF? Well, is it because the bond in HF is nonpolar? Hydrogen has a lower electronegativity difference when nitrogen compared to fluorine. Electrons are shared equally in nitrogen and the hydrogen NH3, or does hydrogen have a partial negative charge in both molecules? Okay, so let's write out the facts and then we'll start introducing topics to get to the correct answer. Now, we have two compounds here. We have NH3, and for this, right, we're not doing Lewis structures. This topic is not structured around making correct Lewis structures. Nobody cares about that. The only thing that we have to be able to decipher is the specific type of bond in this compound. And it seems like for nitrogen and hydrogens, right, NH3, there's gotta be a nitrogen and at least one hydrogen bond, right? That's the bond that we're talking about. So we have a nitrogen bound with a hydrogen. Okay. Now, let's go to the other one, right? They did say that HF as well. So, in this case, I'm just going to flip it on its head just so that we have the elements aligned right? It's a fluorine bound with a hydrogen. Doesn't matter whether you put HF or FH, it's the same thing. But I did it this way because I want to show you that in both of the bonds, there's one thing in common, that both of them have a hydrogen in it. So when you start seeing similarities, that means don't pay attention to the similarities. Only look for the differences. The differences between these must come from something to do with nitrogen and fluorine. So, they did give us a sentence that said that the NH3 bond is less polar. So, something has to do with this nitrogen, as opposed to it saying that the nitrogen is making this bond less polar, and by default, that would mean that the fluorine is more polar, making the bond more polar, right? Okay, so we have to find out why. Well, when we're talking about polarity, right, whether it's polar, nonpolar, polarity, dipole, all these P words, that always comes from electronegativity. So we need to know electronegativity. So we need to know the general trend. Well, here's my lovely little box for a periodic table. Here's my electronegativity trend. And this one is easy to remember because it's the corners, right? It's the two F corners. The lowest electronegativity is in the bottom left corner, being francium. And as we increase to the other corner with the big bad boy F, this is the highest electronegative element. And maybe I can just whip this a little bit closer. Whee! Okay, cool. So francium is the ultimate lowest electronegative element. Fluorine, on the other hand, is the ultimate highest electronegative element. Well, would you look at that? In the question, they gave us the higher electronegative element, the highest one. So that has to do with something about polarity. Because of this, we know that fluorine is the higher electronegative element, which means that nitrogen would be less electronegative. Okay. Now, when you're talking about differences in electronegativity, this all comes back to attraction in this bond. So if I strip away this, and I kind of draw the region in which those electrons are going to be, here's my two dots, 1, 2, and here's my two dots, 1, 2. Since fluorine is the most electronegative element, it's going to pull, it's going to have the greatest attraction, and the electrons are basically going to be all the way to fluorine. And fluorine's like, we'll share, but not really. Nitrogen, on the other hand, since it's less electronegative, sure, there's a little bit of a pull, but it's not going to be as great as fluorine's. So I'll draw this a little bit pulled over, but for fluorine, this is a greater pull. Okay, so now let's see, right? Now also what we can do is we can talk about this idea between nonpolar and polar. But if you have a pull, like we do see in HF, that is totally a polar bond. So fluorine being the most electronegative element, chances are if it's with anybody, it's going to be a polar bond. So by this one saying that the bond in HF is nonpolar, that's immediately not correct. Nonpolar means no pull. This would be equal sharing between the two atoms. Now, just know that when you pull the electrons, you get partial charges, partial positives and partial negative charges. And just know that the one that has having the highest electronegativity is going to be the one that is more partially negative. The word is literally in the word electronegativity. So the higher the electronegativity, that's the partial negative. So for fluorine, right? That means that since this guy is the highest electronegativity, you tell me, would this be partial negative or partial positive? Yeah, partial negative. And the other one would by default have to be partial positive. So the same type of idea here. Even though there's a little bit of a pull, but not as much as fluorine, nitrogen still is the one that's pulling. So this would also be partial negative, which makes hydrogen being partial positive. Also keep in mind that nitrogen is like right around here on the periodic table, and hydrogen's all the way over here. As you go from left to right, you do increase your electronegativity value. So nitrogen and fluorine would both be higher in electronegativity than hydrogen. So for this one, where it says hydrogen has a partial negative charge, the partial negative always means that it's the higher electronegative element. But that's not correct. This should have been partial positive. So this one's down. Now we're down to these two. Now for this one, we did say that there was a little bit of a pull, right? There is some type of electronegativity difference. Hydrogen's all the way over here, and nitrogen is on the left side. So there has to be a difference in number. Literally, the electronegativities have to be different. So if they are different, they're not going to be equally shared. They would be unequally shared, as we've seen when we pulled the electrons more closer to nitrogen. So this one's out. So by definition, by process of elimination, it would have to be this one. And hydrogen has a lower electronegativity difference with nitrogen compared to fluorine. Keep in mind, if the hydrogen electronegativity is the same, keep in mind, let's just say, usually it's like 2.2. And fluorine has the highest electronegativity, maybe, usually it's 4.0. Nitrogen by default is like 3.0. If we subtract these two numbers, the HF one is gonna be the greater difference. It's gonna literally be a higher number than if you subtracted 3 and 2.2. That's what this one's talking about. Hydrogen has a lower electronegativity difference with the nitrogen compound compared to that with the fluorine. And that is the final answer. And this breaks my heart. If you guys know me. Maybe, hold on. Maybe I could do this. I'm going to say, it breaks my heart. I have to go over that writing, but let me see. If I scooch it in, will it grab it? Oh, that's okay. That is totally okay. Okay, and that's it. I hope this helped. Let me know in the comments. Thank you so much for viewing the video. You could also check out our website, glazersguide.com. The link is in the description for more problems like this, more practice problems. We have big general overview videos where you could grab your favorite drink, grab some snacks, and let's hang out. Let's hang out and learn together. All right? So check it on over. It's a cool website, if I don't say so myself. But yeah, I hope you guys are having a great day. And here comes the outro music. I'll see you guys later. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.